Hello everyone, I am Xiao Gang. Let's take a look at this flag. This flag is actually similar to our tear rate, but it's slightly more complex than the tear rate. We have already discussed reverse. It can guarantee memory allocation in advance. So we are essentially pre-allocating the capacity of this memory. Then, when you deallocate, you don't need to add these elements. Also, we can remove or release the objects inside, using reset or empty, that is releasing the object or releasing the memory, depending on your choice. If you only need to release the object, you can just use reset. If you also need to release the memory, you can just use empty. And then, regarding the slack, its main select element is, it mainly makes it convenient for us we don't need to allocate resources every time we add an object. Instead, we can utilize the memory that has already been allocated, but it hasn't used it. So, when removing elements, it is also very efficient, because when removing, it doesn't actually remove it, but just says, this just means it hasn't truly released this block of memory, but rather releasing this object instead of releasing the block of memory that the object occupies. So everyone needs to differentiate between these concepts, right? Actually, it's the same as when we designed our database. For example, during the development process, we often use a database to store a user table. So sometimes the user doesn't want this account, they just delete it. But actually, this information won't be deleted from the database. It just has an identifier in the database identifying that this user is out of time. It's equivalent to being frozen. That's what it means. Because if you delete, this data will truly be gone. If you want to go back and look for it, it's really troublesome. But if you put a marker on it, marking that it's deleted, then the user won't know. The user will know that it's deleted. So it's deleted, and then TMap might not be able to do anything. Using this max function like that, to check the number of pre-allocated functions, this piece of code, it first guarantees that this map, it can store at least 10 elements. Then it adds 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 10. Equivalent to adding them in. After they are added in, this container, it looks like this. And then if we, at this point, we can use this to find it. We can just look at hilt. Maybe this is from an older version, or maybe they typed it incorrect. We can use hilt to remove these empty elements, right? And then, if we remove this hillock, it is removed from the end section of the zone. Then these things in the middle of our zone, then it might be impossible to remove. At this point, you will need to package it and compress it, squeeze it all together. Then, this allows us to remove some invalid element, as you can see here. It's equivalent to the grid positions, removing those with an even k. That is the elements where k is even. For example, right? And then click it again. You'll notice that only this part at the end has been removed. In fact, there are no blank spaces in the middle. Then if you need to remove all of them, you'll need to compact it, and that should be enough. So, let me demonstrate it for you. Now let's take a look in VS. When this TMap makes some changes here, what does it look like? Okay, let's start writing this code now. Regarding the naming of this code, I think what name would be appropriate? Let's call it Slack. Okay. Let's create it. And then, over here, just call. You actually don't need to call. You can do it too. Write it yourself. New map. And over here, we still use int as the key parameter. And then intersensor can continue our values. As for this part, actually we don't really need to compare these values. But let's just put it in anyway. How do I enter this freight? Like this. Then we won't need that negative transport loop. Let's just write it manually ourselves. I'll write this down manually. Okay, we have already written this manually on our end. And after that, we need to go and remove some element. So we remove. Let's just write it ourselves directly. First, we definitely need to remove this k. It must be k type over here. This element, which is k2. Note that it is a function. We are not accessing it. 2 4 6 8 上. Okay, removing this place actually just releases the object. what it implements, its memory area hasn't actually been released. Right, after we finish removing it, we call this Cyric once. We let it sample points. At this point, it actually only sampled the element at the end. So if we compress it first, making it bunch up, then we let it sample and reduce it a bit. Let's look at the effect. Okay, finally, we give it an inner sense too, as a segment point of our symbol. Okay, I'm going to prepare to debug the function here. We will come directly to this segment point later. Okay, we'll slow down a bit here. We have entered already. Then we can do it this way first. Okay, we first assigned a TMap. At this point, there shouldn't be an area allocated for this memory. As you can see, this native data shouldn't contain anything. Right? Okay, let's move down. After we add 1, take another look. It's still the fruit map. This is our first element. It is displayed right here. Then we need to go there and take a look. You can see this data. It should be this data. We still need to go deeper and look for it. Let's look here again. Okay, please note that it's like this. We have given it a number here. You notice this number. There is nothing here in this place. You can see, primarily observe these elements, okay? After we add an element, note that we haven't used this reverse function here yet. We will show you the reverse function later. If we don't use the reverse function now, let's see what it looks like. Let's add an element here. You can see that the element here is like this. This is fine. Then we continue moving down. We'll keep adding all 10 elements until they are done. After adding them, there are 10 elements here. Notice that we're looking at this element here. There are 10 here, right? Then we now start deleting it. After we remove it, you can see that it's 9 here. This is normal. Or add pairs run value elements. This spot, look at this spot. There's one here from invired, right? There's an invired one, and then you can see that this is its lower level. We don't need to look at these lower level things. We should focus on this part. This is invired's part. Now, let's proceed downwards. Let's look at this again. Look here. Here. You can see it, right? We will now remove these 2, 4, 6, 8, and 10. Okay, we can see it. Here and then our elements. You can see 24, T, 6, 80, 110. That is the 10 of them. Let's shrink it a bit. Hey, you will find that 2468 is no longer in the 10. Let's compress it. Hey, you will find, right, this one. This thing is changed, right? Then we can run Cyric here. It will basically delete all these extra spatial elements. You see? Okay, we have completed the execution this way. Okay, actually, this area combines the empty spaces together and then systematically removes all the elements. So we are going to add reverse to it because we are currently adding it dynamically. What if we allocate it in advance? First, let's allocate the physical space and try it out. Okay, we will start it directly now. Later, we will go directly to the endpoint. Okay, let's enter the endpoint first. Let's define an empty one here. Then we can see the empty one. It currently looks like this. It's completely empty. They were originally all empty. Next, let's redefine it. Oh, you can see that max here equals 10. Look, this element has 10 invalid ones. If you share at this point, all 10 will be removed. Let's add it here, like filling it up with these 10 things. And then we remove it here, right? Look, remove. And then in this spot, notice and observe this element. See? Here you can see that if we, right, this place of ours is equivalent to, we have removed this 268. Then in Cyric, this segment is equivalent to this max. It gets deleted later. Then we compress it. Then we let it Cyric. Okay, then the execution is complete. The process is generally like this. Look, this is compressing the set of constructed data and then removing the voids in the middle. Then this Cyric is equivalent to, it just reduces the set of this structure and avoiding this, avoiding empty code. Okay, So regarding the slack, we have finished explaining this section.